In this video, I'm going to solve this problem using the alternating series test. You have an alternating series right here. We want to show that it converges, or we want to show that it diverges. So to use the alternating series test, we kind of need to make the following assumptions. If you have an alternating series and it satisfies these three conditions, then the series converges. So the condition number one is limit n approaches infinity, a sub n is equal to 0. Then condition number two is a sub n is positive, and condition number three is a sub n is greater than or equal to a sub n plus 1. So individual terms go to 0. That's the first condition. Second condition is that each of the terms in the series is positive, excluding this sign here, okay? And a sub n is greater than or equal to a sub n plus 1. That tells you that the terms coming in the future are smaller than the previous ones, okay? All right, so let's go ahead and check each of these conditions for this one. So obviously you have limit n approaches infinity, a n is going to be equal to limit n approaches infinity 1 over ln of n. As n goes towards infinity, ln of n goes towards infinity as well. As a result, 1 over ln of n goes to 0. So that's good. So this checks. Number two, ln of we start from 2, right? So ln of 2, ln of 3, ln of 4, and it keeps going. These are all positive, okay? So we are good there. Next, ln of a sub n is greater than or equal to a sub n plus 1. So ln of n is obviously less than or equal to ln of n plus 1, which is pretty clear, right? Then 1 over ln of n is greater than or equal to 1 over ln of n plus 1. Because I took the reciprocal of this, so that means that this inequality in the middle is gonna reverse or switch. Another way you could think of it is this. I kind of want to show that as well. Obviously, n is less than or equal to n plus 1, right? So if you apply ln to both sides, you're going to get ln of n is less than or equal to ln of n plus 1, right? It's kind of like saying 4 is less than 5. So let's say, here is an example. 5 is less than 6, sure, less than or equal to 6. So in that case, 1 over 5 is greater than or equal to 1 over 6. If you have difficulty understanding this, think of it this way. 1/5 of something must be greater than 1/6 of something, right? The same thing. Okay? That's how we should be thinking. So applying that logic, we could say 1 over ln of n is greater than or equal to 1 over ln of n plus 1. So all these three conditions have been satisfied, okay? All condition 1, condition 2, and condition 3, all three have been satisfied for this series. Therefore, by alternating series test, this series converges, okay? So it converges. I hope that this discussion was helpful. Thank you very much.